Okay, so let's check out this example here. In this problem, we're told that we have a 40-meter chain, and it's currently hanging vertically from a cylinder. So what that means is the whole chain's hanging. How far above the ground? But the whole chain is hanging. That's a different situation than if you had, say, a 40-meter chain, but it's only being wound up onto a cylinder that's 10 meters above the ground. Well, then, the remaining 30 meters of the chain would actually be laying on the ground. And so you'd be doing a different type of situation there. But here the whole chain is hanging vertically from a cylinder. That cylinder is attached to a winch. We're told that the chain has a density, so we're treating this as kind of like a point thing. The density of the chain is actually constant. It's 9 kilograms for every meter of chain. We're going to use standard 9.8 meters per second squared as our approximation for the acceleration due to gravity. So we're asked the question, how much work is required to wind the entire chain onto the winch? So first of all, we know that work is equal to the integral from A to B, whatever lengths we're doing, of our force function that we're exerting. So this time, since we're doing it vertically, I'm going to call it f of y dy. So that's my work. But I need to figure out what my force function is. Because sometimes when I've wound some of the chain up, I'm not lifting the full weight now, right? I'm not lifting the full weight. Initially, my winch needs to lift initially the full weight, all 40 meters of chain weighing 9 kilograms per every meter. Or in other words, it takes a force of 300. I got to lift 360 kilograms worth of chain, initially. But then as I wind it up, if I'm halfway through, 20 meters is on the drum, I'm not winding that 20 meters anymore. I only have 180 kilograms. So the amount of force I have to exert changes depending on how much chain has been wound up. So that's the first observation to make. The amount of force I'm going to have to exert is going to change. Actually, I was just talking about mass there. Right? The mass is changing, which means the force I'm going to have to do is also going to change. So here's the picture. Right? We have a winch, and we have a chain that's 40 meters long initially. But again, as the winch starts winding around, right, some of that chain is going to be, wrapped up, and you're no longer lifting the full mass. So what we have to realize here is I need force, but the information that I am given initially refers to mass. But remember that force is just mass times acceleration. And we know the acceleration due to gravity is 9.8 meters per second. That's what we're going to be using, the 9.8 meters per second. Okay. And so that's the first thing we have to realize is that we're going to need to use a mass function here. First, come up with the mass. How much chain do we have? What's the mass of our chain? I don't want to say weigh because weigh is actually force. But we often think of kilograms, same as we think of pounds, as a weight, even though it's really a mass. So what's our mass? Well, our mass depends on how much chain's there, right? How much chain's there depends on how much have we already drawn up. If I've drawn up half of it, then the mass is now in half. If I've drawn off only a quarter of it, then I still have 3/4 of the mass. So our mass function here is just the mass, density of the chain times how much chain do we have? Well, if we've wound up y meters of the chain, then we have 40 minus y meters remaining to lift. Right? And so that would just be 360 minus 9y. And then force, the force that we need is just the mass times the acceleration. So 360 minus 9y times 9.8 meters per second. Or you can actually just call that g for the moment if you want, understanding that's a constant. So that's the force that we have to exert. And then we're lifting the chain from 0 meters of chain lifted all the way up to the whole thing, 40 meters. So our work then would be 0 to 40 of 9.8 times 360 minus 9y dy. And at this point, we're just going to go and use our technology to work this problem out. So, math fn int, integral 0 to 40 of 9.8 times 360 minus, minus 9x, because my integral is set up to integrate with respect to x. And close that parenthesis. And so we find out it's going to take 70,560 joules of work. 70,560 joules of work. Okay. Now, in the homework, you're going to run into a problem similar to this. And it's actually going to have a part B where it says, what if we now add a weight onto it, the end of the chain? So we're now lifting the chain and that weight. Well, we're always lifting that weight. So the force required to lift that weight will just be the force to lift the chain plus whatever object we're laying. That'll be our force function. Right? So then we can, again, evaluate our integral of the new function. So if like we were lifting, for example, a 25 kilogram weight, then our force function would be this piece plus the constant 25 kilograms of weight. So again, you're going to run into something similar to that in the homework.